Now that we have talked about the equations that we need for drag, let's talk about a little funny thing that I found on the internet. It's for a 40-inch speed chute parachute. It's a trainer that apparently you can buy for about $70 that will help you train you with your speed and stamina and strength and acceleration as you go down the track. I just thought that was a funny thing I wanted to share with you guys. So additional information for a little bit, I want to talk about what is terminal velocity. So let's watch as the skydiver falls from the airplane and watch what happens to his parachute. So once the parachute opens, so this guy is falling, note what's happening to these numbers right here as they keep changing until a certain point when they come to 0 and acceleration goes to 0. So now watch this again. He's starting to fall. Force of gravity acting on him is 1,000 newtons. As he falls, the drag keeps increasing, and his acceleration goes to 0 when the drag equals the force of gravity. So one more time, let's look at it. So acceleration downwards is about 10, which is 9.8, but we're around after 10. So as the force increases, his acceleration goes to 0, and that is the point of terminal velocity. When the upward drag force equals the downward pull or acceleration due to gravity of the Earth, that is what the terminal velocity is. Note, his acceleration goes to 0, however, he will still continue to fall. It's just that he's not falling faster and faster. That's how the raindrops are, right? They start from a certain speed, they accelerate to a certain point, and then they keep falling, except they're not accelerating anymore. Again, if I was to do a free body diagram of this person falling, the first effect is going to be mg, which is the weight of this object falling downwards due to the acceleration due to gravity. Drag force is acting upwards, and the arrow is smaller. When this drag force arrow becomes equals to the mass downwards, that means that this object has reached terminal velocity. Now let's try to answer those concept questions that we were talking about before. If dropped simultaneously from the top of the Empire State Building, which weight will hit the ground first? Again, our possible answers are mass 1, mass 2, or both will fall at the same time. So you should be able to answer that with absolutely mass 2. It will fall faster. Then concept question 2 was, if dropped simultaneously from the top of a table in our classroom, which weight will hit the ground first? Mass 1, mass 2, or both at the same time? Yes, they will both fall at the same time. Another important factor that hinders the motion of certain things, of all things, for example, projectiles, are when you have a projectile launched forward. If there was no air resistance, then these projectiles set off with an angle, say 45 degrees, with an initial velocity of 100 meters per second, will go about 900 meters. But when the air resistance is turned on, this will only go 600. So when you are firing a cannon, you also have to take into account air resistance. So all your equations are going to change. The velocity, the acceleration, and all those equations change when you have air resistance in it. So drag is a very, very important thing to consider in a lot of situations. So the last thing I want to talk about before we move on is another concept question. The concept question is, a heavy rock is dropped out of the window of a moving car. At the same time, a ball is dropped from rest from the same height. Neglect air resistance. Now, important to note, we are neglecting air resistance. Which will reach the ground first? The rock, the ball, or both will hit at the same time? Question 2. Which will hit the ground with a greater magnitude velocity? The rock, the ball, or both will hit with the same speed? So again, there are two different questions. One, it's talking about the time, and in the other one, he's talking about the speed of both of them, right? A rock is heavy, and the ball is light. Okay, they're both dropped from rest from the same height. Yes, the answer is they will both hit the ground for the same time. However, the velocity of the magnitude of the velocity will be greater for the rock because it's heavier.